So here we have a particle which is moving along x-axis starting from origin, and the acceleration versus position graph is given by this parabola. The initial velocity of the particle at the origin, so if this is the x-axis where the particle is moving, then at the origin the velocity of the particle is given 3 meters per second. And as it moves, there is some acceleration, and that acceleration is not constant, remember, it is variable, and how it varies with x they have given in the graph. Now at x equals to root 3 meter, somewhere here let's say, so when x is root 3 meter, the tangent to this graph at this point x equal to root 3 makes 60 degree is also given. So at that point we have to find velocity and acceleration of the particle instantaneous. Okay, so how do we solve this problem? Remember, we cannot use here s equal to ut plus half at square and the other two formulas, because those formulas are for constant acceleration. So here we have to use obviously calculus. Now since a and x graph is given as a parabola, so we can write parabola equation as y equal to some constant times x square for a graph which passes through origin and is parabolic like this. This is the equation. Now who is the y coordinate here? A. K is some constant. Okay. So to find acceleration at any coordinate x, we must know the value of this k. Now to find this k, we need to see what is given in the question. They have given you that angle made by tangent at this point, which is 60 degree. And whenever you know angle made by tangent to a curve, it means tan of that angle will be the slope of the curve at that point, right? Slope of the tangent at that point. And slope in calculus is dy by dx, isn't it? Here y is your acceleration. So they have given you slope at this point. So using that information, we can try to find k. So let's try to do that. Here theta is 60 degree, and what is dA by dx? If you take differentiation of this, you will get k will come outside, right? Differentiation of x square will be 2x. Now tan 60 degree is root 3, and this is at which coordinate? This is at coordinate root 3. X equals to root 3, right? This whole thing is at x equals to root 3, remember. They have only given you the slope at this point, for which x is root 3. So x is root 3. So root 3 gets cancelled. So k is nothing but half. So once you know k is half, what will be your acceleration? Half x squared. So once you know this, therefore at x equals to root 3, they want velocity and acceleration. So at x equals to root 3, what will be acceleration? Root 3 square will be 3 by 2, 1.5 meters per second square. So this is your instantaneous acceleration, and this is the value of that acceleration at coordinate root 3 meters from origin. Okay. Now how to find velocity? Well, normally if acceleration is in terms of time, then we write acceleration as dv by dt, isn't it? Then we cross multiply, and then we integrate to find velocity in terms of time. But here acceleration is as a function of x. So that time we should use this formula for acceleration, v into dv by dx. Now those who don't know how this formula comes, it's quite simple. We already know a is rate of change of velocity with respect to time. So let us multiply with dx and divide by dx. Right? So if you cancel dx, you will get the same thing. But dx by dt is what? Rate of change of position is velocity. So this formula of acceleration is quite useful when you know a in terms of x, because then you can cross multiply and integrate. So please use this formula here because we know a is in terms of x. So what is a? X squared by 2. Instantaneous a, remember. So substitute the a which we found. Then you cross multiply and integrate. So x squared dx by 2 will be v dv. Then you integrate. Now initial velocity is 3, remember, not 0. So let's say initial velocity is u, final velocity is v. Initial coordinate is origin because it started from origin, and final coordinate is x. So we need to integrate this quantities. Okay. So this integration will give you half will come outside. Integral of x squared dx will be x cubed by 3. Upper limit is x, lower limit is 0, so you will get the same thing. Here you will get v squared by 2, integral of v dv, but limits are v and u. So remember, this is not 0, okay? So this will give you x cubed by 6 equals to v squared by 2 minus u squared by 2. Now they want at what coordinate the final velocity when x is root 3. So when x is root 3, this is root 3 cubed by 6. Right? That will be equals to v squared by 2 minus u. Initial velocity was given 3. 3 squared by 2. Now this will be how much? This can be written v squared minus 9 divided by 2 LCM. Then 2 and this 6, if I divide, I'll get here 3 root 3 square can be written as 3 root 3, right? This is what? Root 3 times root 3 times root 3. Root 3 into root 3 will be 3. So 3 root 3 and 3 cancels. So v square will be minus 9 will come this side, 9 plus root 3. So final velocity will be under root 9 plus root 3 meters per second. Okay.